Chapter 4, Section 3, Grandmaster, some critical thinking problems. In this video, we're actually going to look at some equations as opposed to expressions. Okay, an equation is basically when you have two expressions that are equal to each other. So you have a left side and a right side, whereas before we didn't have a left or right side. We just had a statement and we tried to simplify what was already written as best we could. Right. So here we want to solve for n, meaning we want to determine what number n is. So in theory, n can't be anything. We're hoping it's a specific value, some mystery number, and we're trying to find it. But x to the n divided by x to the minus 3, we are told is equal to x to the minus 5. Well, this left-hand side, okay, I can do stuff with that. Okay. The right-hand side, I'm not going to do anything there. Okay, whatever I do to change one side, I must do to the other, but I'm not going to change anything. I'm just going to simplify. When you're dividing powers of the same base, remember you get to subtract the exponents. So this is just x to the n minus negative 3. So watch your minus signs. Okay? Well, n minus negative 3, that's the same as n plus 3. Okay. Now, we don't care what x is. From this point, x could be anything. But since the bases match on each side, okay, if these expressions are equal to each other, that means the exponents must also be equal. So n plus 3 must equal negative 5. So I'm actually just going to pull this out and create a new equation. So that must mean n plus 3 is equal to negative 5. It has to be. Let's solve for n. I can do so by subtracting 3 from both sides. So n is negative 8. Okay. And we can check that. Okay. Let's replace this n in our minds with the number negative 8. Okay. Negative 8 when we did the subtraction of exponents. Negative 8 minus negative 3, that's the same as negative 8 plus 3, which is, guess what? Negative 5. So this has to be correct. Let's try another one. I have some ugly mess on the left, and on the right I have 81 over x to the positive 12. Okay, so n only appears once here. That's what we're trying to figure out. So I think the best thing to start with, let's leave the right-hand side alone. Okay? And let's just try and make the left-hand side look a little bit nicer without actually changing what it says. So this negative 2, I can apply that exponent to both the numerator and the denominator. So let's do that. So this becomes x to the n plus 1 to the negative 2 over 9 to the negative 2. Okay, so I have a bunch of junk, each of which is being raised to the power of negative 2. That's still equal to this. Okay. So I'm going to have them switch positions. So it becomes 9 to the positive 2 up here, and then this becomes x to the n plus 1 to the positive 2. Okay. Well, 9 squared, I can work that out. Let's write this here. Okay. 9 squared is just 81. I can see the sides are starting to match. And when I have a power being raised again, I get to multiply the exponents. So it's 2 times n plus 1. So I'm going to have to apply distributive law. So that's going to give me x to the 2n plus 2. And again, if you're not sure how I got that, this is what I did. And I'm just multiplying those exponents together, but I have to apply rainbow rule. This is 2n plus 2. Okay. So now the left side and the right side are much more easily comparable. And the 81s correspond, the x's correspond, they're all in the same position. So in order for these two expressions to be equal, this 2n plus 2, whatever it is, that has to be 12. Okay? If this does not work out to 12 as it does here, then there's no way these two expressions are equivalent. So I'm going to forget everything else, and I'm just going to work with this now. The fact that 2n plus 2 must be 12. So I've created a new equation that's pretty easy to solve. I'm going to subtract 2 from both sides, which gives me 2n is equal to 10. Now I'm running out of room here, so I'm not going to show the division. But if I divide both sides by 2, they will cancel here, and I'll get 10 over 2, which means n is 5. So you can write it below if you have more room, but I'll just put it here. N is 5. Okay. It's the only number it could work out that n could be such that this expression would equal this one on the right. Example 3. All right, I have 4x to the power of 7 over 2 times nx to the power of negative 1/2, and that we are told is equal to 12x cubed. Solve for n. All right. Well, notice that n is, well, it's not part of an exponent as it was in these two examples. It's down here. But again, our right-hand side looks pretty simple, so I'm just going to work with that. And just going to try and tidy up the left side. Just try and simplify it as best we can. So this is just straight multiplication. All right, this is 4 times x to the 7/2 times n times x to the negative 1/2, and so on. So I'm going to write it like this. Let's see, 4x to the 7/2 times n x to the negative 1/2. Because really I don't even need those brackets anymore. Okay? So 4 times n is just 4n. Okay? And x to the 7/2 times x to the negative 1/2, we just get to add the exponents. All right? So 7/2 plus negative 1/2, well, that's the same as, here, I'll show you up here. This is what I'm working on right now. Plus, I'm just adding the exponents together. Okay. Okay. 7/2 minus 1/2 is 6/2, or 3. So this becomes x cubed. Okay. So if we compare the left side to the right side, well, we have x cubed and x cubed. That's all good. Well, for everything to hold, that 12 and that 4n must be the same. So from that, I'm going to create a new equation. So I'm just going to ignore the x cubed. And there we are. That's pretty easy to solve for. So n is 3. Because 4 times 3 is 12. So I would have 12x cubed equals 12x cubed. That one is done.